Hi everybody, welcome to Stroma Insights number 4 with me, Stuart Oakes, and my colleague
Sarah Rogers.
Do you want to just quickly introduce yourself, Sarah? What are you around here?
Yep, I'm Sarah Rogers. I am the air sealing and testing manager at Stroma Built Environment. I have been with Stroma for almost 15 years.
From school.
I wish.
So thank you for joining me today, Sarah. Today I entitled this podcast Air Testing in Small Places, because air testing is not only about doing whole buildings for Part L, which we've talked about with Adam previously on this series, but it's also required for other purposes. Today we're going to specifically cover room integrity testing, plenums and smoke shafts. So without further ado, we'll begin. So first of all, we're going to talk about room integrity testing. So just a bit of a background. So we've spent a lot of money on building a state-of-the-art gas suppression system in a room or a space that essentially that we want to keep fire out of by getting rid of the oxygen in it. And the sensors are all primed and the cylinders are full of gas and all the data's safe. But there's a catch then. If that room or space can't hold that gas, that the inert gas for at least 10 minutes, and the whole point of what you've done is probably irrelevant. Is that true, Sarah?
Exactly, yeah. I mean, I think that's what makes it so elegant as a test. You've got a room with potentially hundreds of thousands of pounds worth of gas suppression, infrastructure, anything that you need protecting. A whole system demands on one thing, and that room can actually hold the gas enough for it to do its job. You don't want to be left in a situation where you know that room is inadequate, and the only way of knowing that is either getting the room integrity test done or unfortunately having the building set on fire and the inevitable happens. Yeah.
And I think as we talk about that at the moment as well, also the insurance companies are going to be very interested to know that all this data, all these whatever they are, being protected.
Yeah, exactly. It's part of the insurance policy anyway on any room integrity or any gas suppression system, that it is within that realms of your certification that you do have that tested on a yearly basis, and it should be checked, it should be maintained, and it should be tested every 12 months. That's
key, isn't it? Annually. Don't just do it once and forget about it.
Absolutely. There's many companies out there. I had this tested 5 years ago. It's absolutely fine. There's nothing being done to it. There's nothing being, even a movement joint could make that, fail its room integrity test. Just a slight movement, if it's a new build, even if it's an old building that's been refurbed, somebody just putting a fibre cable through, for new data cables, something that doesn't really warrant thinking, that won't make a difference. It does in a room integrity test, because you are measuring that really small adjustments to that room. So, in general, you do need it done on an annual basis.
Cool. So just take us through what you actually do to carry out one of these tests.
So standard air test sort of requirements, we come in sort of an hour, 2 hours to set up, check all of the gas bottles, everything that we need to check beforehand, we do that, ensuring that everything is as it should be on the data sheets. We obviously look at what's supposed to be installed versus what is installed, just to double check that you have got the right gas suppression system in there, because that's something that we've come across from time to time, is just the fact that people have noted down that they've got an old gas suppression system in when they've actually had an upgrade, but the new gas bottles or everything is not exactly where it says. Again, that could invalidate a warranty or an insurance document. So we double check all that for you, make sure that that's all correct, signed off, all the T's crossed and the I's dotted, and then we get down to testing. So it's as simple as just doing a pressurised and a depressurised test.
So we use the same equipment as we do on buildings,
same
basically.
Equipment, yeah. We don't temporary seal any ventilation. That's it's a misunderstanding from the industry at the moment. A lot of people are going in and temporary sealing the damper systems on there. They're there to do a job. If we're temporary sealing them and then we blow air in, for instance, and they open at a certain threshold, which they shouldn't be opening, the gas is gonna leak out. So we purposely don't do that.
So this ultimately has to be a realistic test of real life conditions.
It has to be a real life test, yeah. As though the gas is gonna go off. That's how we would replicate that test. Ensure that that's then held for so long. We pressurise and depressurise up to 50, 60 pascals. We do it in 10 pascal readings, and then we calculate the leakage retention time.
And what units do we use for this?
We use it in pascals of pressure, and we use it for minutes rather than leakage area.
Okay, so what will be a good reading? I know averages is difficult because different circumstances for different rooms are different.
Yeah, so generally you're looking for over 10 minutes of retention time, purely because that gives the fire brigade enough time to get there and then, to suppress the fire. That's then potentially going to burn down that building. It should be enough time to give you that retention time to make sure that
So it's all about buying time.
It's buying time.
As with any fire, of like a fire door to stop penetration of fire. This is just to stop the air leaking out and fire getting in. Now you mentioned cable penetrations, but is there anything else that you want to be looking at in terms of what might cause failures?
Door seals are a big one. Brush strips degrade over time. If you've got poorly fitted frames, worn threshold seals, structural creep as well, especially on new buildings. So if you've got obviously new buildings that are going to move and shift for the first sort of few years at least, you could have retention cracks. Anything that's then going to cause slight cracks. It might only be a small hairline crack, but you don't know what's going on behind that facade. You don't know what's going on behind that internal plasterboard, and realistically that might have opened something above the ceiling void, where that is. So
with anything, particularly with anything as critical as fire, checking is better, forewarned is forearmed, and for the cost of doing this over the potential of what could happen, it's a no-brainer really to use a cliched expression.
Absolutely.
We talked about the insurance requiring this as well, so there is a regulatory thing driving all of this.
There is.
And then there's always this interesting thing about this, what we call in the structural safety, which is about if the room is too tight. I know this is probably not realistic and doesn't happen very often, but I think it's worth just finishing off on that, isn't it?
Yeah, I mean, for room integrity wise, the onus shouldn't be on too tight, because at the end of the day, the damper system will do its job. It will hold, the gas within the room for the amount of time that it needs to, until it's manually opened and the gas can release. Now, if that is, maybe it's taken 20, 30 minutes, 40 minutes for the fire brigade to get there, for instance, that's only saving the servers, anything that's then protected within that room, that's doing its job. So yeah, in air tightness, yes, there is such thing as too tight. In room integrity, I wouldn't have thought that. In my opinion, it's never too tight.
Well, thank you for that. I think it's kind of covered the relatively simple process, and and hopefully, as with any kind of insurance policy, which I suppose you could put this into, it's when you don't have to claim no one cares, do they? It's just that 1 in 1,000 or 1 in 100 times that something bad's going to happen. You kind of wish you had done it. So as we've said, every year it needs doing. So perhaps put it on your reminder list to ring whoever's doing it, or give us a shout.
Absolutely.
So that's room integrity testing. Next thing is this wonderful world of plenums. So the underfloor. But Sarah, do you just want to give us a what is a plenum and why it's so important to get it right?
Yeah. So essentially, a plenum is space within underneath the floor that you're walking on. So you're in an office, for instance, and you've got a tiled floor. 9 times out of 10, you're going to have a space between that floor before it hits the deck, which is the concrete slab. Now, sometimes these are just open spaces, sometimes they're just empty spaces, sometimes they're what's classed as a plenum. Now, plenum is a pressurised space between the floor and the underside of the slab, which is there to do a job. It's there to distribute air throughout that space. It's there to...
Is that for air quality reasons?
Air quality and heating and ventilation systems as well. So the HVAC system will normally feed into there to distribute air. If they haven't got an overhead one, then generally it's an underfloor one, which is called a plenum test. Now, obviously that needs testing purely on the basis of if that's leaking on the external facade, for instance, you're going to waste a hell of a lot of money feeding that plenum. That's then just going to distribute out on the external facade rather than actually
you're making a horizontal chimney, really, aren't you, if you're not careful?
Yeah, exactly. That's exactly what we're doing. What
you're trying not to do.
Yeah, yeah, for it to go, to escape.
So one of the key concepts that we talk about when we're talking about plenum testing is static pressure and airflow. Do you want to give us a couple of lines on the differences and what that means?
Absolutely. So it's worth noting, or worth distinguishing between these two. So think of it like a garden hose with loads of holes in it. The tap might be running at full pressure. It's running. It's fantastic, brilliant, but it's not really coming out on the end. You're trying to water your garden and there's not really much coming out. At the original point, it's great, it's running like mad, but at the end result, you're not really getting anything because you've got that, you've got that
leakage throughout
the hose.
Or the plenum in this case.
Yeah, or the plenum, exactly. So, at the plant space, you can measure it, it's working perfectly fine, but at the end result, you're not really getting what you need out of it. So realistically, that's where the static pressure and the airflow comes in. So it needs to be able to be retained within that plenum. So therefore, if you've got loads of leakage areas into risers on the external facade, for instance, you're not getting that, that constant pressure within that plenum, which then obviously you're going to waste a lot of money, time and resource trying to find where that is. Just from having a plenum test done, that would eradicate any doubts about what the actual output is from the HVAC system.
So it's all the same when we talk about air pressure testing. It's being in control of where air's leaking and not leaking where you don't want it to leak, and knowing what you do, knowing what's happening rather than just assuming what's happening is the right thing to happen.
Exactly.
And then the first thing you find, the first time you're aware of anything is when something odd is happening, like it seems to be costing more to heat a building or cool a building or something like that. Yeah, you
get your DEC at the end of the year and it's 4 times as much as you were expecting to be spending on your...
Bring back some money, it's worth doing then, isn't it? Yeah. You've talked about the garden hose analogy. What are the common failure points and what's the best thing to do to sort those problems?
Perimeter sealing. Almost every time where raised floors meets the walls, you often get gaps where it's not properly addressed during fit out. They have openings up as the building's settled. Just general, construction work. Any penetrations generally that are going through are sealed, fire stopped. But in general, they are one of those. Again,
sort of forgotten about areas, aren't they? Because you can't see them.
Yeah, as soon as the floor goes down, as soon as the floor plate goes down, that's it. You can't really see that perimeter line. When we come to do the testing wise and it does fail, we have some really skinny guys that just go under the plenum and crawl around and find the areas, which is great for us.
If we haven't got skinny guys, is there any other way you can do diagnostics?
We do. We do smoke diagnostics as well, so if we don't have any skinny guys on site, which I'm not one of them. Yeah, we use smoke diagnostics, so essentially filling the void up with smoke, pressurising it and watching it come out at the external facade. Now 9 times out of 10 that is right. Sometimes it's pipes, conduits, data cables running through the floor into the voids. We've seen it into risers where it hasn't been sealed into the HVAC system properly. All these are potential leakage paths and should be sealed before the floor plate goes down. 9 times out of 10 it isn't, so that's where we have the issue. That's
the common problem with air tightness generally, isn't it? When things get forgotten about, they're out of sight, out of mind. Even in a house, you put a bath panel on and there's a big hole through the wall with the plumbing. It's the same. Air will just get out. Well, that's really useful, and sometimes, as you say, because they are out of mind, and as you said, you're probably walking on these things every time you go in the office. But again, awareness is key.
Yeah.
Knowing what you're doing, knowing what the potential problem is, and get it checked, because getting it checked is not costing you. You can fix it, you can move on, save money, because you're not wasting heating up air that's getting out the building unintentionally. So that was Plenums. And then finally today, not last but not least probably, smoke shafts, the final sort of sub-subject of testing small places. So do you want to just Take us through that.
I love smoke shaft testing. Smoke shaft testing is probably one of my favourite things to do because...
There you go, listeners, you heard that first here.
Sad as it is. Smoke shafts, so in 14 years that I've been working at Stroma, I've probably tested, hundreds and hundreds of smoke shafts, and I can count on two hands how many times they've passed the first time. I don't understand why, after all these years, smoke shafts are still forgotten about.
Do you want to tell everybody what a smoke shaft is?
Yeah, so a smoke shaft essentially is a vertical corridor that runs either side of a building. That's in visual wise. So 9 times out of 10 you'll see a grill on the front of it, which is like a mechanical grill. Now what happens is when there's a fire in a building, for instance, the smoke alarms will go off. The smoke shaft grills will automatically open, and there's a really big fan at the top of that top of the smoke shaft that will draw the smoke out of the corridors to ensure that people get out safely out of a building. Imagine a corridor that's full of smoke, you're going to come out of your apartment or wherever you are, and it's going to be full of smoke. You're not going to be able to see your exit signs.
And it's smoke that is in some ways more dangerous in fire situations.
Absolutely, yeah. So a smoke shaft is absolutely essential. They are required under building regulations. They have got a standard figure of 3.8, no matter the size. So if you've got the tiniest little smoke shaft in the world, or you have a 37-storey high-rise building, it's still 3.8 cubic metres of leakage. That is the standard rate of leakage, and the government, or the building regulations, do put that figure on there because it is essential for any building smoke shaft to work correctly and to work the way that it should work. Now, if you were to, for instance, say, if you were to test a smoke shaft and it were leaking into an apartment, for instance, through a cavity wall, all that's going to do is going to draw the smoke out of the corridor into the next apartment. Now, that's not safe. That's not how it should be done. It should be equally as important as a full building test, even more so because it is to do with the safety, not just the consumption of electricity.
And you mentioned these are requirements of building regulations, so obviously when a building's built, is there any ongoing requirement to have these tested?
Yeah, so no, not for not regulatory elements. No, generally nothing goes in and out of a smoke shaft, so they don't get maintained, they don't generally get
very much a passive measure, aren't they?
No, yeah, exactly. Nobody's feeding any cables or anything into a smoke shaft after it's been built. Once it's been built, commissioned. I do believe that there is commissioning that needs to be done, but I'm not sure on how. No,
well, that's not our game. Our game is to check that the actual shaft itself fulfills a certain amount of air tightness, and hence the amount of plant on it to draw the smoke out is enough to do so.
Yeah.
Well, I think there's just one of those things you probably don't think about in buildings, but you would absolutely be, can't talk about money here because it's about people's safety, and smoke, as we've said, is going to kill people.
There is, in really old, in old buildings when they don't have these installed and something happens, 9 times out of 10, it is the smoke that's killing people.
Yeah.
It's not the fire. It's not or even the imminent danger of falling.
Yeah.
Because they can't see. They can't. That is to do with safety. So, it's a killer. Is smoke, and it really, if they don't take the measures in getting this right and making sure that this is working correctly, is tested correctly, and is signed off correctly. Then people's safety is paramount, and it is a dangerous thing is not having your smoke shaft tested, commissioned and signed off by the right people.
So we don't want to finish this on the sort of on the negative. Obviously, the reality is, but I think the message we want to get across today is, buildings are going to need air testing. I think everyone kind of knows that now. But if you're building particular kinds of buildings which have room integrities are very, very specific to particular kinds of buildings for particular kinds of purposes. But, most, if not all, high-rise buildings now will have smoke shafts in them, and most commercial buildings that we build now have got plenums in them. So kind of don't forget about that. We can do that. We're very experienced at doing that. We have we have the expertise. We have the skinny people to go between us.
We do. We definitely do.
And we can advise. And with anything like this, early stage involvement is great because, we can test before things get buried with things like Plenums and make sure that that we can do it at a time when things can be put right more easily than the last thing we ever want to do with anything is wait till the end of a building to do any kind of air test on it, or do any kind of test on it really, because if it's not going to work, if it's failing, then you're taking things apart, you're breaking things you've already put in, you're double handling things, so the cost becomes more expensive and the time becomes more, which is often the cost, becomes far more. So hopefully food for thought for everybody there. Please do get in touch if any of what we've been speaking about today is relevant to you and you want to have a chat about it. So I thank Sarah very much for her time today. Very interesting.
Thank you.
And we look forward to speaking to you soon with the next podcast. So for now, thank you very much and goodbye.